Welcome back. Tonight we're going to review bivariate statistics and correlation coefficient and regressions. So let's get right to it so we can keep the video short and sweet. Page 1-2. Until now, you've been looking at one variable statistics, which are also known as univariate. Una for one, variate for variable, one variable. But it's often more useful to compare two sets of data. When we compare data as pairs of numbers, that data is bivariate, two variables. On page 1-3. For example, a pediatrician may compare the height and weight of a child in order to monitor growth. Or the owner of a gift shop may record how many people enter the store with the amount of money made each day. Those are both examples of bivariate statistics. Page 1-4. So there's a spreadsheet on the next page, and it shows the mean value of the critical reading and math sections of an exam for 9 schools in Ontario County, New York. We're going to review how to make a scatter plot of the data and describe the relationship between math and critical reading scores. So if you go to page 1-5, you can see there are the scores, math and critical reading. You can scroll through. There are 9 comparisons. So we'll add a data and statistics page. And we don't know what depends on the other in this case. We don't know if reading scores depend on math or math scores depend on reading. I might lean toward math scores depending on reading because you have to be able to read first and do math later. So let's call math our dependent variable, put it on the y-axis, and creative reading or critical reading, I guess, on the x-axis, our independent variable. And there's our scatter plot. It's certainly going in the positive slope direction, so we'd call that a positive correlation. If you drew a line through that, it'd be moderately close to all the points, so maybe we call it a moderately strong positive correlation between critical reading and math scores. Let's go back to page 1-5 or 1-4 and make sure we answered the questions. We made a scatter plot and we described the relationship. That's all you needed to do there. For the sake of review, oftentimes really in this class, you will want to model that data with an equation. So from your graphs page, you push menu, analyze, regression, and in this case we're pretty sure it's linear. We'll go mx plus b in this course, and there's the line that best fits the data. Y equals 1.15-ish, x minus 66.99 or so. Alright, moving on, page 1-1. We would like to measure the strength of the linear relationship between the variables in a set of bivariate data. The number we use to measure both the strength and direction of the linear relationship is called the linear correlation coefficient. The letter R is used to represent that relationship. And again, this is review from way early in the year when we started talking about functions and linear functions. So on page 2-2, here's an example. Coach of a basketball team made a table of attempted and successful baskets for 8 players. This table is given to you on your data sheet in your new packet. You're going to make a spreadsheet and scatter plot of this data, and then find the equation of the line of best fit and the value of the linear correlation coefficient, R. Remember, you need to get that on a calculator page with an analyzed regression. So you're going to add a list and spreadsheets page, enter your data, add a data and statistics page, see your scatter plot, find the equation, add a calculator page, and run the linear regression to find R, the linear correlation coefficient. I'm going to leave that for you to do. I will put the pages in very quickly for you to see and check your work, but this is another good time to pause your video, do the work, and make sure that you can remember how to do that. If you already remember and you're certain, just fast forward right on through. 3.1. Page 3.1 is a second example. Very much the same. I gave you data on your data sheet. You're going to enter it, make a scatter plot, look at R, and explain if a conclusion could be made by this produce manager. Again, pause the video, get the data entered, check your answers against mine. On page 4.1, I need to warn you that the correlation coefficient is a number that measures the strength of the linear relationship between two data sets. However, just because there seems to be a strong linear correlation between two variables does not mean that one causes the other. There may be other variables that are the cause of the observed pattern. We can never, or we should say rarely, prove anything in statistics. You certainly can't prove anything with just a linear correlation model or correlation coefficients. Be very careful about believing everything you read or hear in the media. Statistical studies is a powerful phrase used to make you believe something to be true when often it isn't. For example, one statistical study noted the relationship between the amount of ice cream sold and the number of drownings. They found a linear correlation coefficient of 0.9978. That's pretty darn close to 1, so we would call that a strong, positive linear relationship. But does that prove that eating ice cream increases your chances of drowning? Of course not. People eat more ice cream in the summer when people are swimming more often. So there are underlying variables, the season and when we swim, that affect that relationship. It's not that eating ice cream causes drownings. So just be careful. Don't get tricked. Okay, the last thing I want to remind you of is that not all relationships are linear. In Algebra 2 and Trig, you'll be asked to find other regressions. The process is exactly the same. You just choose the appropriate regression on your calculator. Now, that is only true for Algebra 2 and Trig. In statistics courses, college statistics, AP, bridge courses here at the high school or when you go off to college, you won't use those other regression models. But again, in Algebra 2 and Trig, you'll be asked to. So, to your linear relationship on page 1.6. You could have gone to Menu, Analyze, Regression, and remember there are all the choices. So when you're asked to find an exponential regression, you show exponential. Power, show power. Quadratic, show quadratic. We can do logarithmic. We can do sinusoidal, sine curve. Logistic is not something we do in Algebra 2 Trig. So your choices will be sinusoidal, logarithmic, exponential, power, sometimes cubic, and certainly we could do quadratic and linear. So that's the only difference. Everything else is the same. Make a scatter plot and find your equation according to the directions in the problem. And that is it. Hopefully that's a nice short review. Have a great evening.